everyone, we will be presenting on Lactitol, a fascinating synthetic carbohydrate that has gained attention for its versatility in the food and pharmaceutical industry. What is Lactitol? Lactitol is a sugar alcohol derived from lactose, which is the natural sugar found in milk. It is a disaccharide composed of galactose and sorbitol, linked by a beta-1,4-glycosidic bond. So, let's explore its structure, synthesis, properties, application, and health implications. How is it made? Lactitol is synthesized through the hydrogenation of lactose, where the glucose portion of lactose is reduced to sorbitol. It can be crystallized out as a mono or dehydrate as well as in an anhydrous crystalline form. This is the Howard projection of lactitol. Finally, the chain conformation shows how the atoms in a six-membered ring are arranged in 3D space. This specific arrangement helps the molecule avoid steric strain, which occurs when atoms or groups are too close to each other, that causing repulsion. By minimizing steric strain, the molecule achieves a more stable and low-energy configuration.
Now we are going to discuss the synthesis of lactitol, a sugar alcohol derived from the lactose. Let's dive into the process and break it down step by step. Lactose is a disaccharide, meaning it's made up of two sugar molecules, beta-D-galactose and beta-D-glucose. These two units are connected by a beta-1,4-glycosidic linkage, as you can see in this structure. The glucose unit in lactose contains an aldehyde group, which plays a key role in the synthesis of lactitol. The synthesis of lactitol involves catalytic hydrogenation, which is a type of reduction reaction. In this process, first, lactose is dissolved in the water to form a solution. Second, hydrogen gas H2 is introduced and the reaction is carried out in the presence of a catalyst, usually nickel. These reactions occur under moderate heat, 100 to 115 Celsius, and high pressure, 30 to 60 atm to ensure efficiency. The key chemical change happens in the glucose unit of a lactose. The aldehyde group at the first carbon of glucose is reduced by hydrogen gas. This reduction converts the aldehyde group CHO into the primary alcohol group CH2OH. The result is lactitol, a sugar alcohol where the structure of lactose remains largely intact except for the conversion of the aldehyde group in glucose. In summary, lactitol synthesis is a straightforward but fascinating example of catalytic hydrogenation. This combination of heat, pressure, and a catalyst transforms lactose into lactitol.
Let's move to the properties of the lactitols. The physical description of lactitols is either crystalline powder in solid form or colorless solution in liquid form. Lactitol has density about 1.52 gram per centimeter cube. Melting point of lactitols is approximately 146 degrees Celsius to 150 degrees Celsius. When compared to fructose that have 186 degrees Celsius as the melting point, lactitol is lower. In terms of solubility, lactitol dissolves readily in water with solubility of about 700 grams per liter at 20 degrees Celsius. Lactitol is poorly soluble in organic solvents such as ethanol. One of lactitol's key advantages is its stability. It remains stable under heat at across a wide pH range. Unlike some sugar, lactitol does not decompose easily in acidic condition. When it comes to sweetness, lactitol provides a clean and mild sweetness that is 30% to 40% as sweet as sucrose.
Now, application of lactitol. Number 1. Food industry. Sugar substitute used in sugar-free and reduced calorie products like chocolates, candies, baked goods, ice cream, and chewing gums. Lower glycemic index. Suitable for diabetic-friendly product as it has minimum impact on blood glucose level. 2. Pharmaceutical. Laxative, used as a treatment for constipation by increasing the water content in the colon to soften stone and stimulate bowel movement. 3. Medical nutrition. Incorporated into dietary supplements and special dietary formulation for people requiring low calorie and sugar restricted diet. Lastly, number 4. Cosmetic and personal care. Occasionally used in oral care product like toothpaste and mouthwash due to its non-carcinogenic properties and mild sweetness.
There are several side effects of an overdose of lactitol. The first one is upper respiratory tract infection. NURT is a common viral or bacterial infection affecting the nasal passage and throat. The common examples include the common cold and sinusitis. Next one is flatulence. Flatulence is an associated gas which is particularly in the initial stage of its use. This occurs because lactitol is a non-absorbable sugar that reaches the colon largely intact, where it is fermented by gut bacteria. Next one is diarrhea. Diarrhea occurs when it is used in higher dose or for prolonged periods. This happens because lactitol draws water into the intestine, which is an osmotic effect, to soften the stools and stimulate bowel movements, which is how it works as laxative. However, this mechanism can lead to loose stools or diarrhea if the dose exceeds the body's tolerance. The last one is hypertension. Hypertension, or increase in blood pressure, is a condition where the force of the blood against the walls of the arteries is consistently too high. It is often referred to as a silent killer because it can cause significant damage to the cardiovascular system without obvious symptoms.